Okay, so now we'll be formally starting our discussion for a technical topic for today, that is operator overloading. So I'll just give you a quick revisit of what we have seen so far, and today we will try to conclude this topic as well. Okay, so let me just quickly discuss whatever we have seen previously. So you see, operator overloading is basically a useful concept which allows us to use operators with objects of our own classes, right? Previously, we said that you cannot use operators with maybe with integers, you can use plus or minus or multiply or relational operators, right? Maybe b greater than c and so on. But if these a, b, and c are objects of your own classes, right? Maybe the point class or the complex number class or any other class, then we cannot use these operators, right? So however, if we implement operator overloading, then we can use these operators with objects of our own classes, just like we use them with basic data types. Okay. So for that, we had seen plenty of examples, right? We had done some examples with the point class, with the complex number class, right? So what we have done so far, we have been overloading binary operators in which we have seen plus, minus, and I told you that similarly you can overload multiplication, division, and so on. And we have seen relational operators, so which you can like less than, greater than, equal to, not equal to, and so on, right? So all of these were binary operators, which means they take two operands, right? If I am doing addition, I need two things to be added, and those things are called operands. Okay. So so far we have done operator overloading using member functions. Member function means a function which is inside a class. Okay. So if you remember, the key idea was that when we were calling this writing a statement like this, so at the back end, a function is called in the point class, right? Assuming P1 and P2 and P3 are objects of point. So what happens is that when the function is called for P1, so you don't need to pass P1 as input, and whatever is on the right side of the operator, you pass it as an argument, right? So this was the discussion we had done so far. Okay. So now we'll extend this discussion, and today we'll be overloading some unary operators, right? We had done one example, right? But now we'll do it in more detail, and more specifically, we'll be starting our discussion with increment and decrement operators, right? So just to quickly remind you that suppose if I have an integer x, so if I write plus plus x, so it is same as adding 1 to x, right? So this statement is like x gets the value x plus 1. Okay, so instead of writing this, you have a you can say operator which is called increment operator, which has two versions, prefix and postfix. So we'll see both of them, but we'll be starting with the prefix version. Okay, so let's try to overload this operator for a class. Okay, so let's make a different class this time, right? Maybe not the point class. We'll do the with the point class later, but let me just write some class, say counter. Okay, and we will be overloading the increment operator for this class, and of course same you can do for the decrement as well. Okay, so let me just take some data in this class, maybe a single data member, right? So let me call index. Okay, and within the public, what I do, nothing much, just a constructor and a get function. Okay, so I can write counter int, say a, and here I can write x gets the value a. And similarly, I can make a function int get x, and here you can write return x. Okay, so you can of course have other functions in this class as well, but let's restrict ourselves only to these. Okay, so let's now come to the main and see what we want and how we are going to achieve that. So here I write, say, counter c1, and I pass it 5. Okay, so what is actually happening? This is your C1. It has only one data member, which is X, and we are passing 5 to it. Okay, so constructor is setting the value, so X gets a value 5. Now, suppose we want this to be a legal statement, plus plus C1. Okay, of course, presently it will not work because this operator is not overloaded. So if you try to write it, it will give you an error. Now we want to make it a legal operator. For that, we will make a function. Okay, and name of the function, let's, for the time being, let's not give any output. So I'm just writing void. Later we can change it. Okay, so name of the function you already know. You have the keyword, which is operator, then the symbol of the operator which you want to overload, right? And then within the body you can write whatever you want to do with this. Okay, so you see, whenever we overload a operator, we actually decide what we want to do. Okay, so now this is a class counter, and when I write plus plus c1, I will decide what it should do, whether it should add 1 or 2, or it should double the number. It depends on our requirement, right? So let's keep the requirement similar to how this operator behaves with integers, right? Normally when you write plus plus, it means that you are trying to add 1 to that integer, right? Now in our case, we have this class which has one data member, which is x. So when I write plus plus c1, then the most logical thing that comes to our mind is that we should increment this x which is in this class. Okay, for example, when I write this 5 should become 6. Now it is also possible that, suppose instead of counter, if it was a point class, so in case of point class, you have x and y, maybe 2 and 3. Okay, so what this, if I write plus plus p1, so you have to decide whether it should increment x or y, or maybe both of them, right? It depends on what is your requirement. So since you are overloading the operator, you have complete liberty to decide that what it will do. Okay, so let's do it with this counter class, and then maybe we can extend the same idea to the point class as well. Okay, so we say, okay, whenever someone writes plus plus c1, we want that 1 should be added to this data member which is in the counter class. Okay, so what I should do here, maybe just one single line. If I write here plus plus x, okay, so now you see our job is almost done. Why is it done? When I create an object c1, x is 5. When I write this statement, this function is called. When this function is called, I write plus plus x. Now this x is of c1, so it will become, from 5 it will become 6, and the function will conclude. So you see, our job is done, although not it can be improved, but for the time being it is done. Another important thing you must have noticed is there is no input to this function. There is no argument, right? Why there is no argument? Because when I write plus plus c1, this function is called for object c1. So the data of c1 is already available in this function. I don't need to pass it, right? If you remember, when we were writing p1 plus p2, we said function is called for p1. So you don't need to pass p1, you only need to pass what is on the right side. But this was a binary operator. Now we are dealing with a unary operator. There is only one object. There is no second object, right? So when there is one object, the function is called for that object. So no argument is required. Okay. And last time there was a discussion as well. Some of you asked. So basically, whenever there is a binary operator, the number of arguments is 1. And whenever there is a unary operator, there is actually no argument. Okay, so this will always be like that. Whenever you are doing operator overloading using member function, if it's a binary operator, you will have one input. If it's a unary operator, you will not have any input. Okay. Okay, so let me just clean it, and then we improve this, you can say, function. So presently we have this situation. Okay, but you see, when we are using this operator with basic data type, for example, when we are using with integer, so we can also have a situation where I can store the result somewhere, right? For example, if x is 6 and there is an integer y, so I can also write y gets the value plus plus x. Okay, so what happens here, x will become 7 and y will get the value 7. But in this case, if I try to do the same thing with my class, okay, so maybe I will not be able to do that. And the reason is that the function is not giving any output. So what we are trying to do, we say, okay, let's take another object counter c2. Now suppose someone writes this. So when you write this function is called, but since this function is not returning anything, the return type is void here. So that's why you cannot copy that value because the function does not have any output. So if you write this, this will give you an error. So since it is similar to what we did with the point class, if we want this to be a legal statement, then we will have to return something from that function. And what do we return? Again, you see, when you are incrementing a point, the answer is also a point. Similarly, in this case, you are incrementing an object of class counter. So when you increment that, the answer is also an object of class counter, right? So what you can do is here, sorry, instead of the return type void, you can write the name of the class which you want to return. So you will write here counter. Okay, and what do we do in the body of the function? You just take counter, which is your answer or result or output, and you say answer dot x is this x, and here you write return answer. Now let me explain it stepwise that how this will execute. Okay, so let's get rid of this and stepwise see this, and then I will also write this program. Okay, so what is happening? You have counter C1. This is C1, which has 5 in its X. You have counter C2. Default constructor is called, so there's 0. I assume there's 0. Okay, and then you have this statement. When you write plus plus C1, this function is called. Now what is happening in this function? The first statement is plus plus x. This x is a data member of C1, right? Because you were using the operator with C1. So what will happen? The 5 will become 6. So let me just update it. So 5 will become 6. So let me write the updated value. This will become 6. Next, since you have to give an output, you take another variable of this class, which we are calling answer. Now you write answer dot x gets the value x. So it means this will get the value, which is this x6. So this will also get a value 6. Okay. And then your final statement is return answer. When you return this, where it will go? It will go to whatever is on the left side of the assignment operator, means it will be copied in C2. So C2 will become 6. And since the function is terminated, so this variable is now destroyed. Now you see, when this statement is executed, C1 has 6 in its data member, C2 also has 6, and it is exactly the same behavior that we observe in case of integers, right? Because we decided that we'll be doing like that. If there were integers x and y, you write plus plus x, so x is incremented and the incremented value is also copied in y. So same thing is happening here because we wanted it to be like that with the counter class. Okay, now let's write this program, and then maybe we can discuss further and extend this program to other scenarios as well. Okay, so let me maybe I can get rid of this and I can make the counter class. Okay, so let's just clean things a bit and then okay, so I'll quickly make the counter class, class counter. Of course, it can be any other class. So I write private, say int x, or in public, I just make a constructor, and I can make a get function. Okay, now we have to overload the operator, the increment operator. So we said counter operator plus plus, right? Again, why it is not accepting any argument? Because it is a unary operator. In unary operator, you don't pass any argument. In binary operator, you pass one single argument, right? The first thing we do here is we increment x, right? And then since I have to return something, so I write counter result. Result dot x is x, and then you write return result. So we now come to the main. Okay, here I take an object counter C1, which is 5, counter C2. Okay, I don't pass any value, so by default it is 0. And then I write C2 is plus plus C1. Okay, and you can now write C out C1 and I can write C1 dot get X so that I print the value of the data member which is in C1, and you also write C out C2 where you write C2 dot get X. Okay, so now what do we expect? That initially it was 5. After the execution of these statements, the X of C1 as well as C2, it should become 6. Okay, so let me run this program and let me show you the output of this program. I have shared with you the output window. You can see that the data member of C1 is 6 and that of C2 is also 6, right? Because we first increment and then we copy because we wanted to behave like that. So let's go back to the program and relate our output with our, you can say, source. So this was a function which is called when you are writing this statement C2 is plus plus C1. So when you increment plus plus X, this is actually X of C1 which is incremented, and then you copy it in this temporary variable, and when you return it, it goes back to this variable C2 where you have this, you can say, updated value, right? And just one more thing that you see, instead of writing these 3 lines for returning, there's also, you can say, a shortcut for this. I will not delete them, I will just comment them, right? So that you know that there's also another way of doing it. So what you can do is that instead of these 3 lines, you can write a single line, return counter. Now you see what we are doing. We are creating an object of this class. We are passing this X in the constructor. So an object is created and returned, right? But the difference is that we don't have any name for this object. This is an anonymous object. So when I write this single line, it is actually exactly the same as these 3 lines. In these 3 lines, first I create an object, right? Then I set the value of X and then I return it. Or I could have also done like that, counter result, and I call the constructor, right? I pass it X and then I write return result. This is also the same thing. So instead of all of these, you have a short, you can say, shortcut notation, which is this, that you just write name of the class and you call the constructor. So this is actually same as this one, right? So if uh, in the beginning maybe you can follow to the conventional syntax, stepwise everything, but at a later stage, once you are comfortable with this syntax, you can actually just write all of these 3 statements in a single, you can say, line, right? Okay, so you see, as I told you in the beginning, that when you are using this operator, increment operator, and the same is true for the decrement operator as well. So actually, there are 2 versions of this operator, right? So quickly, just to recall you that you have a prefix version and a postfix version, right? So if I have, say, int x is 5, and there is int y, and I write y is plus plus x. Okay, this is one way of doing it. Another way which I can write just beside it, that you can do int x is 5 and then you have int y, and you can write y is x and plus plus. Okay, so you see in both the cases we are doing this using the same operator, but on the left side your operator is after the variable or operand which is x, and on the right side your operator is before the variable. Okay, so all of you, I'm sure, know or understand the difference, that what will happen, that in the pre-increment case, first x is incremented and then it is copied in y, right? So x was 5, x will become 6, and then this new value 6 will go to y, right? So this is x and this is y. On the other hand, when you are writing this operator after the variable, means this is postfix. Post means after, so that's why it is postfix. Pre means before, so it is actually prefix notation. So in this case, what happens is that if you write x plus plus, the previous or the original value of x is copied, means y will get the value 5 and then x will be incremented, and now x will become 6. So you see, in both the cases there is no difference in x. X is 6 in both the cases, but y in the prefix version gets the updated value, and in postfix version y gets the original value before you increment. Okay, so now we want this same behavior from our objects of our class, right? We want to be able to use postfix operator with the you can say object of that class which we just made, which is called counter. Okay. Another important piece of information is that you see when you are writing like this, maybe you are copying value, then both of these are behaving differently. But please remember that if someone is writing like this only, plus plus x and semicolon, nothing else, or x plus plus, right? In that case, these are exactly the same. Okay, because when you put a semicolon, it means the statement has terminated. And when the statement has terminated, when you will go to the next line, so x will always have updated value. Okay, so if some of the students actually yeah, confuse this with when you are using assignment operator or when you are using a formula where you are using value of x, that if you are using a statement like you are copying somewhere or you are using this plus plus in a formula, then the behavior of prefix and postfix is different. But if your statement is just plus plus x semicolon or x plus plus semicolon, then there is no difference. Then it is exactly the same. Okay, so please be careful about it. Anyways, coming back to our main discussion, we said that okay, you have a prefix version and a postfix version. Now the problem, there is a problem. What is that problem? That again, suppose this was our class counter, which has everything. I'll not write it again. Okay, so this was your class counter. We said if you want to overload this operator for this class, you make a function and the name of the function is operator plus plus. Okay, and here you have the return type. Okay, and here you have the body of this function. So in the main, whenever someone will use this operator, okay, so this function will be called. This is your main. You have an object of class counter C1 and C2. So someone writes plus plus C1. We just saw that this function is called, and whatever you have written in the body of the function, that is executed. Okay. Now the problem is that if you write it like this, C1 plus plus, okay, then in this function we need something else to happen. Okay, this is not exactly the same thing that should happen, because in prefix version we first increment and then copy, but in postfix version we first copy and then increment. So it means that the body of postfix version is different from the body of prefix version. We agree on it, right? That otherwise they will be the same operator. They will behave, if they have exactly the same behavior, there is no need of having two versions. Okay, so we agree that for that we need to make another function, okay, in the class. So one function for the prefix version, which we already discussed, and we need a second function for this function. So for this version, where we can use the postfix version. Okay, so we need to make another function. Now let's see, if we try to make a function, what would be the name of that function? From our previous knowledge, we know that for operator overloading, the name of the function is operator and symbol. Now symbol is actually the same. Okay, so you see the symbol is same, but if I also use the same name of the function, then this and this, you see they will be exactly the same. So how will you cannot have exactly the same name function with same number of argument in the same program, right? You cannot have two things. Of course, something has to be different. Either the name of the function or the arguments. There has to be some difference. You cannot have exactly same named two functions in the same class. So now there is a problem. Okay, I hope for the first your focus should be on understanding the problem. Then we'll find a solution. The problem is that we are trying to overload this operator. Now, this operator has two positions, before or after. But in both of these, the symbol remains the same. The symbol is actually plus plus. If I try to overload, my previous knowledge tells me you have to make a function and the name of the function is operator plus plus and this. So whether this symbol is coming before the x or after the x, I will have the same name of the function. And this will cause a problem because you cannot have two functions with exactly same name in the same class. Okay, so a solution to this problem is, okay, maybe you won't like it much, but that's the way it is. So a solution to this problem is that for the prefix version we keep it as it is, right? For the postfix version, just to make the function prototype different, they say you can put an argument here. Okay, Now what do we put as an argument here? This int. Now it does not mean that we are passing an input to this function. This is just what we call a dummy argument. Now why is it there? Just to make it different from this version. We will not be passing anything. But you see, if I put an argument, then the prototype of both of these functions would be different. One is not taking any input, the other is taking an integer as an input. So the prototype of two functions is different, just like we have function overloading. But actually, we are not passing any input to this function. This is just to, you can say, cheat the compiler so that your compiler does not complain. When you will write plus plus C1, the prefix version is called. And when you write C1 plus plus after the object, then this version is called. Right? So it's slightly tricky, I understand, right? But let me make the program so that we understand well how things are happening. Okay, so let me just clean it and write both of these functions, and then we'll add them to our program. Okay, so I'll just be making the minimum things which are required. So you can assume that there is constructor and there is rest everything. So I will write, we have one data member which is X. Okay, and then in the public you can make constructor and everything else. So I'll be quickly making the function for the prefix version, which you have already seen. So I will write counter operator plus plus. Okay, and now in this case, this is the prefix version. So what we do, we first increment X, and then we use the incremented value in the result. So I make an object counter result, and I write result dot x is X, and then I write return result. Okay, so this was already happening. This is the prefix version. Now when we'll write the postfix version, okay, so what I will do, counter operator plus plus, and here I'm just writing a dummy argument int so that the prototype of both these functions are different. Okay, now you see in postfix version we have to copy the original value of X and then we increment X. This is the difference. So you see result.x is X, and now I write plus plus X, return result. So let's see what are the differences. There's a very, you can say, just one difference between these two implementation, that in this case we first increment X and then we copy. It means what you are returning will have the new value of X, just like it happens with integers. But here you see we first copy the value of X, which means it is the old value, before we increment, and then we increment. Okay, and just to see the behavior, so in the main, suppose I'll make few objects and then we discuss. So I say counter C1, which is say 6, and C2. So if I write C2 is plus plus C1, okay, what will happen in this case? This is the prefix version. So for prefix, we know which function is called. For the prefix version, we call this function. So this function is called, it means first X is incremented and then it is returned. So it means that C2, after the execution of this statement, C2 will have 7, C1 will have 7. Okay, so this is what we discussed previously. Now let's change these statements, and rather than using the prefix version, let's say what will happen in the postfix version. So in the postfix version, I will write it as C1 plus plus. Now with the postfix version, the function that we have written later, it is called. It means this function is called. When this function is called, so you see we are copying the original value of X in result. So it means it will be 6, and then we are incrementing. So what will happen? X of C1 will become 7, but X of C2 will remain 6, right? Because when we were doing it, C1 was initially 6. When we go to the function, we make another variable which is called result. We copy this 6 in this result, and then we increment it. It becomes 7. And when I return result, this return value goes to C2. So that's why C2 has original value of x, which was 6, and c1 has the incremented value, which is very much similar to how it behaves for integers, right? So let's quickly add this function to our existing class, and then we can see both the versions in action, right? So we already have this prefix version available in the class. Let me just add the postfix version as well. So I write counter operator plus plus, okay? And just to make it different from the previous version, we have this dummy argument integer, okay? So now you see, you just compare the two versions. I see counter result.x is x, and then I increment x and I write return result. Okay, so you see, again, both of these implementations are exactly the same. Simply the difference is that here you are incrementing after copying the value, and here you are first incrementing and then copying. Okay, as I explained to you earlier. So now you can have main, right? You can use this operator prefix version, which is already working. Now I can convert it into postfix version. So in the postfix version, we expect that C1 will be 6 and C2 should have 5 in its data member, right? Because we are using the postfix version. So we can run this program and I show you the output of this. So I have shared with you the output screen. Now you see, when we are using the postfix version, the data member of C1 is incremented. From 5, it has become 6. But C2, since we were using postfix version, it is having the original value of X, right? So let me go back to the program. Yeah, so here you have both of these versions available. Okay, now in the next example, what we'll do is we'll try to use this operator with our, again, our role class, the point class, right? Because it has two data members as we discussed. So let's first agree that what we want to do when we overload it for the point class, right? So we know this is x, this is y, and this is some point, say x is 2 and y is 4. And this is some point p, which is 2, 4. Okay, and this is like this. Just I have connected it with the origin so to get an idea that where it lies. Okay. Now suppose someone writes plus plus p or p plus plus. So what we want to do? Let's agree on it. So we say that okay, we should add one to x coordinate as well as y coordinate, right? Means that if I write plus plus p, then I should get a point which is like here, which is 3, 5. Means you are adding 1 to 2 and you are adding 1 to 4. Okay, of course this is our definition. If you want to change this, it's up to you. You say okay, no, only add in x, only add in y. Okay, then it's your choice. For this example, we are adding in both. Okay, so let's try and quickly write this program. So here we have our class point. Okay, and again, I'll not be making any extra functions. I'll just be writing the data members, and rest you can assume it is there. Okay. So as I always tell you, before writing anything, it's a good idea that you just see what you will write in the main. Okay. So in the main, I will have point say P1, which is 2, 4. And we want to be able to write something like say point P2, and P2 is plus plus P1. Okay, so this is what we'll write. So it means when we increment a point, the answer is also a point. Okay, so it means that the return type would be point. Then I write the keyword operator and symbol of the operator which I want to overload. No argument, so it is the prefix version. Okay, so within this, what we do, we have to increment x and y both, right? So what do? I increment x, I increment y. Okay, and then I have to return it. So I make a point object, say point result. Okay. You can pass in the constructor as well, but if you want, you can write result dot set xy. Okay, constructor ke through be you can actually set the values, and then you write return result. Okay, so when I'm at this statement, what actually is happening? Again, this is P1, which is 2, 4. This is P2, which is 0, 0. There is no value, right? And when I write this statement, the function is called, which is actually, let's see what it is doing. So when I write plus plus P1, I come here. These X and Y are of P1. So actually this will become 3 and this will become 5. And then you have another variable, which is result. You copy these X and Y in result, so it becomes 3 and 5, and then you write return result. So this result actually goes to P2, right? Whatever you return, it goes here. It will get value 3, 5. Okay, so now you can actually add this function to your point class. You can run it and you can convince yourself that this is actually working. And similarly, you can make the postfix version. If you want to make the decrement version, you can simply replace the symbol. Instead of plus plus, you write minus minus. So it means now you can implement 4 versions of this operator, right? Prefix increment, postfix increment, prefix decrement, and postfix decrement, right? You just have to, instead of adding one, you just have to subtract one, and that's it, right? Okay, now we have about 10 minutes, so let's do some discussion, which is again related to the same topic. That you see, for the time being, since we are new to this topic, so every time when I introduce you a class, I tell you, okay, this is the operator we will overload, and then we decide that what we will do within the function, right? But you see, actually, when you have a problem and you are doing operator overloading, you have to choose yourself what operator you want to overload and what should be the logic in that particular function that you will make. Okay, now just to give you an example, you see, instead of point, now let's extend the same idea to something which is called a vector. Okay, so I hope you have seen vector in some physics or maths class, but even if you have not, so you see this is a vector, let's call it v1. It has a starting point, right? Maybe this starting point, I write it, say 3, 3. Okay, and it has an ending point, say this one. So let's call it, say 6, 8, right? So this is a vector which has head and tail. Maybe you are familiar with the terminology head and tail, or you can call it initial point or the final point. So there are actually 2 points, 3, 3 and 6, 8, right? So if you think from the perspective of programming, if I ask you to make a vector class, you can use composition, right? That you already have a point class. So say this is your point 1 and this is your point 2, which is this point. So if I ask you make a vector class, so instead of taking 4 integers, right, you see a good choice would be that you say point P1, which is the starting point, and point P2, which is the ending point. Okay, so this is, you can say, something you can do. But anyways, this was just a side note. Let's suppose now I ask you that for this vector class, you have to overload an operator which can find the magnitude of this vector. Okay, and what is the magnitude of a vector? I'll just remind you, it is like x2 minus x1 whole square. Sorry, this is plus y2 minus y1 whole square under root, means this is the same distance formula, right? So if I apply it on this, so the magnitude of this vector would be 6 minus 3 whole square plus 8 minus 3 whole square under root, and you can compute whatever it is. Okay, so now, but actually this is not the discussion that what is the formula of computing the magnitude. The discussion is that I say, okay, there is a vector class which has, say, 2 points, or you can say 4 integers, irrespective of how you have implemented it. Okay, overload an operator which can find the magnitude of this vector. Okay, so I just give you this. I don't tell you how to do it. I say, okay, overload an operator which gives you the magnitude of this vector. Okay, now as a developer, you have to decide which operator I should choose, whether it should be a binary operator or a unary operator, what should be the input to the function, what should be the output of the function, right? All of these decisions you will make. Of course, some of the decisions are very straightforward, that if it's a binary operator there is one input, if it's a unary operator there is no input, right? But other decisions you have to make. So can anyone tell me, just you can just simply type, for this problem should we take a binary operator or a unary operator? Just think and tell me, right? Okay, you see, when I ask you find the magnitude of a vector, okay, so can you find how many vectors do I have on the board? I have only one vector, okay, v1, and you can find magnitude of one vector. You don't need another vector. For if you have another vector, then of course it will have its own magnitude. Okay, you see what you see on the board, there is one vector, and you can find the magnitude of it. I just found that this was a formula, 6 minus 3 whole square plus 8 minus 3 whole square, and whatever you get as an answer, this is the magnitude of this vector v1. So we don't need a second vector to find the magnitude, because magnitude is of a single vector. Yes, if I ask you add two vectors, then you will need a binary operator because you have v1 and v2. But here I'm just asking you, just focus on the question, find the magnitude of this vector. It means there is a single vector for which you can find magnitude. So if I can find magnitude of a single vector, it means that if I overload it by writing a computer program, then I must choose a unary operator, right? Because if you choose a binary operator, you will write it like v1 plus v2. But why I need v2? I only need to find magnitude of v1, right? So I should not be dependent on another vector v2 if I just want magnitude of v1. You just have a proof here that I have only v1 and I am able to find its vector, right? So the conclusion is that in this situation, if you have this situation, you have, see here I did not tell you, you were decided, or you were required to choose yourself. So when you choose, please be careful. The first decision you have to make is whether I should pick a unary operator or a binary operator. So in this case we have to pick a unary operator because we find magnitude of one vector. Okay, okay, now let me just write the prototype of that function maybe quickly, and then we complete this example maybe later. So just to keep it simple, I'm not taking point, I'm just taking four integers in it, right? Int x1, x2, y1, y2. Okay, so this point is actually x1, y1, and this point is actually x2, y2. So when I will overload a unary operator, what are the choices I have? Right? You just look at your keyboard. What are the unary operators available? This one, even this is a unary operator. You can use it, and this one. Okay. So it means you can choose any of these unary operators to find the magnitude of a vector. It's your choice. Okay, whatever you choose. Okay, so I say, okay, I will choose this one. Okay, so it means if I make a function in the class to find the magnitude of a vector, what would be the name of the function? Name of the vector would be, sorry, name of the function would be operator and this symbol. Since it's a unary operator, so we agree that there is no input. Now, another thing is that what will be the output of this particular function? What would be the return type? So again, so far, all the examples we have been doing, when we were using point, the return type was point. When we are using counter, the return type was counter. But now, do not just write vector here. You have to think, when you compute the magnitude of a vector, what do we get as an answer? Sorry, it is 8 minus 3. If you compute this, the answer is actually a real number. It's a float. It's not a vector, right? Because magnitude is one single number. When you take square root, so it is likely to be a floating point number. So here the return type of this, it should not be vector or something else. It should be float. You see, this is something different from what we have been looking at previously. Okay, I'll complete this later on, but I'm just discussing the prototype. That the first you choose an operator, and then you think when we are adding 2 points, the answer is also a point. So that's why return type used to be point. When we are adding two complex number, the answer is also a complex number. So the return type was also complex. But now we have a different situation. We are computing the magnitude of a vector, and the magnitude of vector is a float. So that's why return type is float here. Okay, so this was just to give you a slightly different flavor, that whenever we are doing operator overloading, please do think then by binary operator or unary operator, and what is the return type, right? So I'll stop here, and we'll complete this example tomorrow, right? But before that, if you have any quick query, we can discuss that before formally concluding.